Hi guys, this is Miss Santos, and this week we're going to be talking about kinetics and equilibrium. Our first topic we're going to be discussing is reaction rates. So, what exactly is a reaction rate? Rate of reaction really just tells you how fast or how slow it takes for a reaction to occur. Different reactions have different speeds, and there's certain factors that affect that speed. The speed of reaction is called the rate of reaction, and the rate of reaction depends on frequency of collisions between particles. So how often do they hit, collide, or cross each other, and the energy in which the particles collide. When we're talking about something that's slow or that has a slow rate of reaction, an example would be something that rusts. When something is rusting, it doesn't rust right away. It takes a few days before you actually see some rust, and it doesn't instantly happen within a few minutes. So that's a really good example for something that has a slow rate of reaction. Other examples of something fast. Think of when you're burning paper or a forest fire. It happens really, really fast, and that would be considered something that has a rate of reaction that is fast. Factors that can affect how fast or slow something occurs would be increasing temperature, increasing or changing concentration, changing pressure, changing surface area, and the use of a catalyst. So let's take a peek at some of these. So all these that are listed here are telling you what increases the rate of reaction. So therefore, that's why we have increased temperature, increased concentration, increased pressure, increased surface area, and increase of a catalyst. What I'm going to show you today is going to be the first one, the second one without the pressure, because pressure only affects gases, the third and the fourth one. So let's take a look at the simulation here real quick. So first of all, let's look at the control. This is a typical reaction, and this is the rate at which the reaction is happening. Okay, if we were to take a look at concentration, and let's say I'm going to increase it, where I'm doubling the amount of A particles and B particles, increasing it makes the reaction occur a lot faster. But let's take a look at what happens when we decrease it. So now we have half the amount of particles. There's less energy, slower collisions, and therefore it takes a lot longer for it to happen. Just think of like when you're in the elevator. When there's just one or two people, there's less likely of you guys interacting. But when the elevator's packed, there's more of a chance of you guys interacting. Let's take a look at surface area. So if we were to increase surface area, think of like a sugar cube. If I were to crush it, that increases the surface area, and therefore when it dissolves a lot faster, right? But let's take a look at what would happen if I didn't, and instead I just put a sugar cube in water. It would take a lot longer for the reaction to happen. Then we have temperature, okay? If I were to try to dissolve sugar in hot water, it would dissolve a lot faster versus low temperatures, it will dissolve a lot slower. So keep in mind, this line right here is always the actual rate of reaction without changing any of these variables. And then last but not least, let's take a look at a catalyst. So here's our catalyst. And when we run the reaction, it happens a lot faster. So that leads to the question, what exactly is a catalyst? Think of a catalyst as a shortcut. It allows for something to happen a lot faster by giving it an alternate route to the final destination. Think of like you can always take the long way home, or you could take the shortcut home. And the shortcut home would be considered the catalyst. It's not part of the equation or it's not part of the reaction, it just assists the reaction. So let's take a look at these checkpoint questions. First one says, as the temperature of a reaction decreases, it is expected that the reacting particles collide. So if you decrease temperature, think of kinetic energy, right? Kinetic energy is going to decrease, therefore the particles are not going to be moving as much. So that means that it would be less often. So it's one of these two. But because they're moving less often, they have less force. So therefore the answer would be D. Next question says, each of the 4 test tubes contain a different concentration of HCl. A 1 gram cube of zinc is added to each test tube. In which test tube is the reaction occurring at the slowest rate or the fastest rate? So for it to happen slowly, it means that the concentration has to be low. And out of all of these, D has the least concentration. So it's going to be the slowest. Fastest rate means you have to have a lot more. So this would be the highest concentration. So it would be the fastest. Okay? So just remember, the more concentrated it is, the faster reaction happens. The more acid you have, the faster you can dissolve a solid. The less acid you have, the slower it's going to take to dissolve a solid. This is another good question. At STP, so remember, STP is standard temperature and pressure. Okay? And it says, which 10-gram sugar sample would dissolve faster? So first of all, these are describing metals, and sugar is not a metal. So the only possible responses could be A or B. And think of when you have a sugar cube in water. Okay? Which one will dissolve faster, the sugar cube or the crushed particles of water? Okay, so the answer would be powder. If you put powdered sugar in water, that would actually dissolve a lot faster than a sugar cube. Here's another one. A catalyst increases the rate of chemical reaction by, and this is what we were discussing earlier, providing an alternate reaction pathway. So that would be A. Think of it this way. Here's this guy, right? And he's going up this huge hill. Okay? It would take him a lot longer to get over this huge hill versus if we had a tunnel down here that gives you a pathway. So if he were to go this way instead, it would be a lot faster for him to go through the tunnel than to go over this big mountain. Okay, so that's the catalyst, the tunnel. Okay, if he would go through the tunnel, he will get there a lot faster versus going over the mountain. So it's the alternate reaction pathway. Which statement explains why decreasing the temperature decreased the rate of chemical reaction while other conditions remain the same? So if I were to decrease the temperature, kinetic energy also decreases. So that means the particles are not really moving as much. So that means they have less energy. So that means C and D cannot be the answer because they don't have a lot of energy if you decrease the temperature. And collisions will happen more often. So the answer for this one would be A. Okay? They're going to react a lot slower than when they're in warmer temperatures. Okay? I hope that makes sense. If you have any questions, make sure to reach out to me and have a great day.